Morning to everyone, and we have a smaller group than usual today. Get a little bit of rain clouds out there and slows people down. We have been listening to the Doors and break on through to the other side. Must have something to do with factoring. Definitely. I have a few questions that have been asked about factoring. One of them in particular had to do with problem 49. So that's page 295. So let's go to there. And on that problem, what you see is a lot of letters in all the terms, but there's one letter that is in every term, and that's what we're looking for. So as we look at this problem, I see an A in each of the four terms. Now the key here is to look for the lowest exponent, and that is the 3. There is no common number, numerical coefficient in all those, so all you can do is argue that a to the third is in every single term. So you could think of factoring out that a to the third or dividing by a to the third and look at what's left. And of course that's the way the answer reads. Contrary to that, 51 is as we look just one more problem right below it, 51 has an x plus 2 that is a factor in each term. So we're looking at what is the same in each term. So if I remove the x plus 2, a kind of reverse form of the distributive property, you're left with c minus d. And so you will have x plus 2 in the outside and c minus 2 left inside. Are there questions that you have about any of the problems you'd like to discuss? Michelle, was there anything you wanted to ask in a particular problem, or?
No, I didn't have any particular.
It's just sort of a generic
problem.
kind of.
It was really like I'm just finding it hard to know where to start to solve the problems.
Okay, and that again, knowing where to start, how to identify what you're trying to do, is always in algebra, I think, a critical issue. So if I look at a particular problem, we looked at 49 just a moment ago. If I look instead at something like 71 and just taking that same idea, okay, 71, and again I'm fighting some glare problems, so I'll just shade that for you. But the key is what to combine together. And I guess the first thought in a problem like 71, just sort of taking that out of the gate, let me write that on the board. I'll leave that on the screen for a moment, and it's a little bit bleached on the far side, but we'll nevertheless write what's there. That's 3a to the third, then plus 3ab squared, plus 2a squared b, plus 2b to the third. Now, as I've written that, one of the things I'm very conscious of as I write the problem is what's alike. That's one of the advantages of rewriting the original problem. Now, in a sense, you're going to have some directions here, typically, and the direction is going to be try to rewrite it as a product, factor out common factors. It would not be meaningful to say simplify, but I think the general phrase here on this particular set of problems is to simply factor, summarize the method of factoring a polynomial with 4 terms by grouping. Well, those are your directions. So the question is, can you always just take it the way it's written? Not necessarily. We saw that yesterday, where by rearranging terms, something worked where it didn't work without the rearrangement. I try to take it as it is first and ask, is it working? If not, then I'm going to try to pull something else together. As it stands right now, as I just look at that problem, the 3's catch my eye, as do the 2's here. So I'm inclined to leave it that way. And I have an A in both of these. So if I take the 3A and then write what is left when I take the 3A and divide it each into these, I have an A squared plus B squared. Then I'm hoping that that's all I'll have left on the right side in one of the factors. So I see the 2b that's also a common factor in the last 2 terms. And that leaves me what I was hoping I would get is an a squared b squared. And in that sense, Michelle, here's something that sort of guides you in sort of intermediate step. If you get an a squared plus b squared here, if you're going to have any hope of doing it, what must then this be? An a squared plus b squared. And if you can't get that, then it says, well, maybe I can regroup, or maybe I made an error. So it's leading you down the primrose path. I need to get an a squared plus b squared, or I can't rewrite this as a product of binomials, which is the hope. Now, once I get to the a squared plus b squared in both, then you have to see that as a common factor, even though itself is in parentheses. And then what do you have left? You have the 3a and the 2b. So I then put the parentheses here and write the 3a and the 2b, and I have my product of binomials. Now, what's not clear at this point is whether the a squared plus b squared can be written as a product. It turns out that it cannot. But if it was a squared minus b squared, then you could do what? Continue, because that is a difference of squares. So that would be a plus b times a minus b. But a squared plus b squared is in prime form. It's non-factorable. So we think of it as like a prime polynomial. Not every problem is going to just go from you start and it just works. You may have to, if you can't find the same factor here, ask, okay, let's try rearranging it. There are times nothing works. And it's just trial and error, and then, of course, frustration is greater. Pam?
Speaking of ones that need to be rearranged, 73.
Okay, 73 the way it is. Okay. It's a good problem to ask about. 73, because it requires a little bit of, well, not just trial and error. 1 minus a plus ab minus b. It's just that minus sign is the dilemma. So you have to be clever. The only thing that looks like can be done is that common b in the last two terms. So you have 1 minus a, and you say, okay, I'll leave that as it is. But then I see that I can take out a b, and I have a minus 1. But what you're obviously looking for is an a minus 1 here, or that would be a 1 minus a. And your first thought is, well, close but no cigar. No, because you could have done this slightly different way. You could have said, let's factor out minus b. Well, let's try that.
Well, then you get a plus.
I'll put plus minus b for the moment, although that's not a necessary step. But what do I have left here then? I have a minus a plus 1, correct? But that's an addition, so I can rewrite that as 1 minus a now in the first part, which I'll just put in parentheses, and note that that is 1 times 1 minus a. And then I have, in fact, I'll just rewrite this now. So much for trying to get the board to clean nicely there. I'm going to write this as just a minus b, and I'm going to take the community property of addition and write that as 1 plus negative a, which is 1 minus a.
Okay.
Now I have 1 here understood, and I probably shouldn't make that look like a k that's backwards. So let's see if I can clean that up. I'm just making a mess up here now at this point. But I'm going to put an arrow here and have the 1 there. So now the 1 minus a is a common factor. So 1 minus a, and I'm left with 1 minus b, and done. Now to see that coming out of this step down here, may not be, well, I guess it was this one right here, where you had the problem. Now if you saw this, another way of doing that is to say you have a minus 1 here. I could rewrite this as minus, so an alternative here is to rewrite that as minus, in parentheses, what? A minus 1. Agreed? So if I treat this as minus the a minus 1, now the a minus 1 is common to everything. So I would have at this point a minus 1 times what? Well, the minus 1's understood here in front, so I'd have a minus 1 plus b. And now the question, are those equivalent forms? That is 1 minus a times 1 minus b the same as, finally, a minus 1 times b minus 1, which is another way of writing that? And the answer is yes, that does work.
Okay.
Because both of these simply have this one and this one. Minus 1 times here, minus 1 times here, minus 1 times minus 1 is 1, so you haven't changed anything, and you're down to here. That particular problem, an important problem.
Well, I ended up rearranging first.
Okay, rearrange it first. I hadn't thought in terms of trying that. What do you suggest?
1 minus b
So put the 1 minus b first,
minus a
plus
ab.
plus ab. Okay, so we get 1 minus b here. Then you took the minus a and have 1 minus b. Okay, and there's an understood 1 here. So you have 1 minus b now times 1 minus a, which is nearly what I had here through the community property of multiplication. Yes?
Okay.
But it is a good problem chasing around minus signs. That is a very important problem just to feel comfortable in doing. The better you feel about that problem, the more comfortable you are with it, the better handle you have of minus signs. Other questions? Then will you fold the papers and go for it. Okay, as those come in, let's see what I can do here, Debbie, to try to get the... Okay, let's cut to the document cam. This is our general category for today, factoring, trinomials, and note, with the way I've selected this, the FOIL gets major billing, sort of like a title of the movie and then subtitle. FOIL, factoring, trinomials. Now, the approach of the author towards factoring in some ways encourages taking a trinomial, making it into a 4-term polynomial, and then factor by grouping. I don't care for it. I think it does make it possible to very methodically do what you need to do, but when you have to factor on the fly, so that could become a nice title for a lecture, Factoring on the Fly. You have to be able to do it mentally, you have to be able to do it quickly, and grouping does not really work all that well, and so I don't encourage it. What I'm going to do is look at the idea of FOIL by looking at some problems where first we start with some easier things. For example, example 3. This is the x squared minus 5x plus 12 on page 298. Now that's a fairly straightforward problem, and the directions are going to be to factor, and let me write it down first, Debbie. And I have x squared minus 5x plus 12. Now, what's involved here is to understand you are going to have 2 binomials. So you can always set a template. And as long as the first term of the trinomial is a something squared, x squared, a squared, b squared, y squared, doesn't matter, you know that you're going to have just the single letter in each. The next step, if your third term is positive, it tells you that these are both going to be negative or both going to be positive. So it's the information of looking at that last term that's positive and the middle term negative that tells me they both must be negative. Now that's a very critical first step. Now the other part we talked about yesterday, and that's looking for factors of 12, not prime factors, but the possibilities of 2 and 6, 3 and 4, 1 and 12. Now we can reverse those, but those are the only ones you have to consider. And if I think of what happens with FOIL, whatever I put in these last part of the binomials, the L part, the outer and inners are going to have to combine to give you a negative 5. So if I put a 2 and a 6, I'm going to get an 8. If I put a 1 and a 12, I'm going to get a 13. So you look at this and you say, well, as I've done it right now, and is this the way that it should have been written with x squared minus 5x plus 12? The question is there anything I can do in one of these that's going to give me a 5 in the middle term given the conditions I have here? Is there anything that's going to work? Your 3, 4, your 1, 12, 2, 6 are the only choices. Can't be done. So at that point you would argue that this is what? Non-factorable in the set of integers. Well, rephrase that. I can't get 2 linear factors. Now, the analysis that goes through here, and let's come back to the book again, Debbie, where you're listing all the possible factors, and then the statement, if I can get down, okay, come off there just for a minute. I don't want to get you dizzy in this process. Finally, we get the phrase prime polynomials. But it's the process that we use, and to know that you're done is because you've tried all possible factors. And note, this is with integer factors. Now, there are going to be ways we have to factor in the set of reals that will give us a solution to what we've tried to do there. But for right now, all we're worried about is this very straightforward process. Let's try it with another problem. And I'm going to jump ahead to a series or a long list. There we go. I'll tell you right now, this is page 317. There are 80 problems. And I'm hunting for something in here that catches my eye. Yes. Okay, let's see if I can get that nice and focused. And let's try this, number 49. Is that reading well? I don't like the way that reads. Okay, let's see if I can try lightening it up. Is that a little bit better? 49. We have k squared minus 11k plus 30. And whether it's x squared, k squared, that's not really all that critical. But this is k squared minus 11k plus 30. It's a similar problem to what we've just done. And that we said was number 49. Now, again, if I'm going to do the same process, notice the analysis here is the same. I'm still going to have 2 binomials. So k and k. Now, as long as we have k squared or x squared, the problem's a lot easier. We're going to complicate it soon enough. Now, what are the things that can be multiplied together to get 30? Well, you can say 310, 215, 5, 6, 1 and 30. Have I left anything out? So I'm interested in putting a negative here and negative here for the same reason we did in the last problem, because the middle term is negative, the last term is positive. Now, the inners and the outers have to total what? An 11, and I'm going to have to put these numbers in the pairs here. So a 310, the total is 13. The 215, the total is 17. The 5, 6, the total is 11. That will work. So I put my 5 and 6 in here, and I quickly do a check. I have minus 5k, minus 6k, that is minus 11k, and I'm done. So notice we're looking at the factors by pairs and asking if the sum of the factors is the middle term. Any question there? Now I'm going to do a slight variation in this problem. And it changes the appearance, right? It's now containing a common factor. So what is the first thing you are obligated to do if you're going to have hope of writing this as a product ultimately? Taking the common factor out, first step. So remove the common factor, then we're at k squared minus 11k plus 30. But if you don't do that as a first step, I think your chances of being successful are compromised. Then we know that we're going to have our two binomials again with the same argument, k in the first term of each, still the negative in each. We still have the 5, we have the 6, but now we have 3 factors in this product. Is there any question there? Michelle?
Why wouldn't it be finished after k
Right there?
parentheses? Yeah.
Because
it's a
what's
product.
left in the trinomial could be factored further. If you do not have a prime polynomial, then you're obligated to factor it further. If my directions are going to be factor completely. So that's the hook. And I'll try to make sure that when we say factor, we mean factor completely. Just like if you write a fraction for me, I expect it to be reduced. That's implicit in the statement. Any question in that one? Now let's have a little more fun. Let's just leave. That's okay. Well, you're fine. I didn't tell where I was going to go, and I was going to just let you stay there for a moment. But let me come back to the page where we are supposed to be. That was sort of jumping ahead. But by the way, you're going to do all 80 of those problems as an assignment on the page we just talked about. So this week. Well, maybe part next week. We'll see. But let's try a little more complicated problem. Something that lends itself to I'm hoping something's here that's a little more complicated because I don't want to just stay doing this same level. Roar. Okay. No. Your author is protecting you rather well. That irritates me. No. I won't truck with that. Okay, let me just, I've got to compare what happens when life isn't so well structured. I'm just going to write down a problem, and I will do it behind me. The problem, and I won't tell you where it is, but let's see if I can find the statement of the problem. There we go. Okay, Debbie, let's cut to that. 2x squared plus 7x plus 6. 2x squared plus 7x plus 6. Because I think it would be a shame to leave you with the thought that everything's going to be possible just the way we've looked at it. I'm still interested in two binomials, so that doesn't change. And as I look at that, I know there's going to have to be an x in the front here and an x here. That's clear. But it can't just be an x. One of them's going to have to be what? 2x. But the question is, as I look at the signs, let's do that first. The last one's positive, so that tells me both signs must be the same, so both will have to be positive. Now that's independent of what else happens. That's a very important first step. We'll look at what happens with the last sign negative in just a moment. Now what are the possible ways of writing a 6? Well, really just what? A 1, 6, and a 2, 3. But now the first term also can be written as a 1, 2, and I'm going to put a 2, 1. I have to provide a reversal of one of the two sets. Either I can provide this one as a reversal or this one. I don't do both. So I didn't need to worry about a 2, 3, 3, 2 as long as I have a 1, 2, 2, 1 here. Now note, doing the inners and outers is still the same problem. So the question, as I look at this, if I take a 1, 2 and a 1, 6, okay, or if I take a 1, 2 and a 2, 3, what would I be multiplying if, for example, this was the 1 here and this was the 2 here, so I have my 1, 2, and I put the 1 and the 6 here, okay? Do you see that that is equivalent to doing this? Let me rotate out. So I can just create the happy face between the pairs. In the same way that I can come here and do this. Now what am I wanting out of these pairs of products I'm creating? For example, here I have a 4 and a what? A 3, and that is the 7 I want. Here I had a 2 and a 6. That gives me 8. I don't want. Let me continue the process. I have 1, 2, 6, 1, and now hold it just a minute. I didn't do that consistent with what I said I would do, so my apologies. Let me rewrite that. I'm going to do the 2, 1 and the 1, 6. I said it only reverse what? The left side. So I do this and I get a what? 13, 12 and 1. Or I could do a 2, 1 and a 2, 3. And that's going to give me what? 8. 2 times 3 is 6, plus the 2 times 1 is 8. Now you can write them in this way, or you can mentally look up here now and say, I've got a 1, 2, and a 1, 6, and in your head, do the inner and outers. So what I'm wanting you to do is this process of 4 different pairings, I want it to be done up here, but in your head. So you do 1, 2, 1, 6, 1, 2, 2, 3, 2, 1, 1, 6, 2, 1, 2, 3. Which in essence creates what we have here. But I want that to be done something you can do in your head. And of course the key was this one right here, correct? Because that gave us a 7. So what does that say? I have my 1 and my 2 in the right spot, but my 2 and my 3 need to be what? Where I had this 1 and 6. So I'm going to replace that. This becomes now the 2, 3, double check, 4x here, 3x here, that's 7x, I'm done. That is the process that we do for the next couple days and the rest of the semester. Okay? Now that's technically what's in the next section. But that's where we're headed. So understand that right now, all we are looking at as we come back now to this problem, we're just doing half the story. I feel like Paul Harvey. I haven't told you the whole story. This is just the beginning part. That's page 1. There's a page 2 that we're going to go to. So after you consider what we talked about here, this should seem rather benign, nice stuff. Boy, I'm not getting any response of niceness there. Well, let me come back to what we're doing today. If you do enough of these, you're going to get good. Let's see. We are in 5.2. Let's see what we have as we come down to page 300. I'm in 300, and how am I going to do this with glare? I'm having a heck of a time with the overhead lighting today. If I get it up at the top of the camera, that seems to help. Now, to put bricks on the page. This is not the way I want it. There we go. That's looking better. Okay, Debbie. We got a whole group of them here. A squared plus 9a plus 20. I want you to look at that. Don't write anything for a moment. I want you to look at it. Now here's our goal. I want to take that a squared plus 9a plus 20. I'm just going to drop that down a little bit tighter. See if I can slide this down a little bit and improve the focus. As you see that 20, I want you to see in your head 120, 210, 4, 5. Now when you say 1, 20, 2, 10, 4, 5, you should be thinking 9 or seeing a 9 while you do that. And I'm hoping that the 4, 5 hits you. That's the 9 you want. I'll just leave that up there for a moment. And Debbie, I'm going to have to head over to the side. We've run out of space up front. But I'll write that first, and then we're going to go to the next one. But let's write a squared plus 9a plus 20. And what you're doing is thinking in this process, and I'll write it down below this time, 210, 4, 5, and of course there's always the 120. Now why is it that I'm worried about the sum of those two factors? What tells me that I want the sum?
Because they're both positive. They're both positive.
The last sign is plus. So that means I want a sum. Now I know they're both going to be positive because the second sign is a plus. Now with that done, we could write this, but you have, I hope, by the time you've written the problem, factored 20 into 4 times 5, and immediately say, okay, I'm going to have a plus 4 and a plus 5. Mentally, you do what each time? Run through the product. In particular, you're worried about what? The inner and outer product. Does that come out 9? It does. Do the product each time in your head just to make sure it's working. Any question there? Now remember, this was third term positive. Let's go back to the document cam. Notice 35. Slightly different wrinkle. We have m squared plus m minus 20. Now in this case, I can still play the same game, the same numbers, and that's what's nice about this selection. I have a 2, 10, 4, 5, 120. That doesn't change. So I have the same numbers involved. But when I look at the binomials involved, how do I have to make them different? Well, both have to be m at the beginning. That doesn't change. But what am I focusing on? The negative in the third term. It tells me in order to get a negative, one of these has to be positive and one has to be negative. Doesn't matter which way you go. But you'll note, if I look at the outers and inners, one will be negative, one will be positive, and in essence, if I add those, I'm getting a difference. So as I look at my 210, 4, 5, 120, I'm not asking for a sum of 1. Please note, the 1 is understood in front of the m. I'm not asking for a sum of 1. I'm asking for a difference of 1. So as I look at my numbers, it's interesting that the 4, 5 is still my choice. Before, I had to have a sum of 9. Now it's a difference of 1. That's okay, but now be cautious. I have two choices. I can put the 4 with the plus sign, or I can put the 4 with the negative sign. So the question, what dictates where I put that 4? The plus 1m. The positive product must be, in absolute value, larger than the negative product. So I need a plus 5 so that when I take 5 times m, that's positive, and my negative 4 gives me a negative 4m, the positive 5m, and I have my positive 1. Okay. Now what's clear is that I could, at the first step here, decided instead to put the minus sign first. Notice here I put the plus sign first. If I do it this way, I still have to have what? The 5m as the positive, the 4 as the negative. So it still works, but note they are what? Reversed. So if you see this in the answer key and you wrote this, you have to understand multiplication is what? What's the phrase I want here? Multiplication is, fill in the blank, starts with the letter C. Commutative. It's reversible. So if you get one product, you can just switch it around, flip it around, and get this other version. If we slide over, Debbie, to the first one we had, I meant to comment on that here because one of the questions I've had asked on occasion, I found this for my answer, but in the back, checking my answers, this was written. Is mine correct? The answer, yes, because commutativity guarantees you that you can reverse the product. Okay in that? Yes, question.
Would you take it down one further step and make it a times 5 plus 4 for that one that's on the camera now?
Right here?
Yeah.
Would I? Yeah.
The one further step where you would take out the common factor, which is the
But
A.
there isn't a common factor.
A is not.
If A were a common factor, it'd have to be a common factor of both terms inside the parentheses.
Okay.
Now, if I took out the A, I would have to have 1 plus 5 over A.
Okay.
I can do that, but it wouldn't be wise.
Okay.
Because it would give me something with a fraction that I don't need. We get the idea? Okay, let's go to the document cam again. Now, we sort of had the same numbers implied that time. Let's try a little different variation. 44. We have q squared minus q minus 42. Now, I want you just to look at the board with me for a moment before you write anything down. If I'm doing this well, and I have you with me, you're seeing the 42, and before you do anything, you're looking at that 42 and saying, 6 and 7 gives 42. 2 and 21, 1 and 42, 3 and 14. But the 6 and 7 is probably the one that comes to mind first because that's one of those multiplications that you just learn. And the 6 and 7 would work because you have a difference. The last term is what? Negative. And so you need a difference of 1. You see, I'm processing those things nearly as I'm writing the problem. I'm factoring 42, and if in my head I say the last term's negative, I need a difference. The difference has to be 1 because that's the understood coefficient. I write the 42, and in my head runs these factors just without really effort. 6, 7, 221, 314, 142, and I see that 6, 7 and say, wait a minute, I'm done. That's where I want you to be today. That you are processing them nearly as you write. Now, if you want to make it a little more methodical, and there are times when you look at it and one of two things is possible. Nothing works. It was intended to be a prime polynomial. Or you're just doing one of those products that didn't work in your head. What do you do rather than stare at it? Well, you come back and say, okay, they both have to be Q. So you are sort of giving yourself something to do, refocus. What I'm counting on, you set in motion some factorings in your head. Subconsciously, if we can get rid of the block, now didn't see it, what am I going to do? Well, I'll write for a while. Okay, now your focus is what? The last is negative, so 1 has to be positive, 1 has to be negative. If you feel I'm being biased towards the plus sign first, you put the negative sign first. Now, I've gotten that far. Then I can draw the happy faces. Anything to occupy your time while your head is sitting there trying to factor 42. Now, that even sometimes gets nice just writing those down, just because it gives you something to do, hoping that something clicks. Now, once I get that, if I'm fortunate enough to see the 6 and 7, difference is 1. The only question that remains is, I want a positive or a negative in that middle term. Since I want the negative, I know that the 7's going to go here, and the 6 here, because whatever is with the negative is going to become a negative 7q. Well, the minute I do that, the only thing that's left is one more time, run it through, and make sure that you have it. Q times Q, Q squared. 6 times 7, 42, negative, that's right. Positive 6q, negative 7q, that's negative 1q, and I'm done. But the key, doing this in your head. For right now, that's as much documentation as I really would want. At some point, you'll be able to look at 60, 70 problems and just rattle them off, doing them in your head, and that's the good kind of thing to do. You get in a setting and you write a problem and just ask people to see it in their head and write the answer. No intermediate steps. Here's the problem, write the answer. Let's go back to the document camp. Okay, I want you to look at 41, do it in your head, and get an answer for me. If it's going to be doable. Okay, still looking at it. Now I selected this as the last one I wanted you to look at in this group for a particular reason. Tell me what, now don't forget where we've been. What do you see in 41 when you look at the last, first and third term? Okay, you see positives, that's good. First and third term, I want you to see something else. Just keep staring at it. They are squares, are they not? Mm-hmm. Okay, they are squares. Interesting. I'll write that up here. And I guess the next question is, so what? As we come to the side. First and third term are perfect squares. Any recognition about the middle term? Okay, they happen to be the sum of the inner and outers, but what I'm hoping you recognized is that you are looking at a TPS. What's the TPS? Trinomial perfect square. Because that's a pattern we've worked on. So let me give you a different kind of problem for a moment. And you may say, my God, where is he pulling this one from? 3/8 and 1/4. Just if you were to add those. You need a common denominator, correct? Mm-hmm. But one of the classic guidelines you give to students when they're first working with problems like this, just check to see if one of the denominators works for both. That is, the 8 happens to be what? A common denominator, the lowest one, because you can change 4 into 8. It's right there, right out of the gate. So instead of doing prime factoring and everything, you say, oh, I can just immediately change the second fraction to the 2/8, and then I have the intermediate step that I ask for in my review of this, and you get the 5/8. Now, the reason I bring that up, when you see a trinomial, you'll go through a mental checklist and say, is it a trinomial perfect square? Is it the difference of two squares? And if it is, without doing anything else, I can get an answer quickly. When do you resort to this process? When it isn't a perfect square. And you're sitting there, and as we scoot that, just tweak it a little bit for me, Debbie. You get a 6/7, a 3/14, and you say, aha, something works. And of course, I could have done what? A 2 and a 21, a 1 and a 42. You don't have to list everything if you can see it and you luck into it right out of the gate. Now, I don't know how hard I'm pushing here. How are we doing? Okay. So far, nobody has eyeballs rolling back in their head, giving me that like, okay, you're dead. Okay, we'll leave that there for a moment, Debbie. I'm going to select another problem. We've got to go to a little harder problem again. I've been giving you some nice problems. Well, nice in my mind and your mind probably aren't going to be defined the same way. Nice for you is a problem that's easy to do. I'm looking for interesting. Okay, so interesting has a little different flavor to it. Something a little more challenging. Okay. Let's try that, Debbie. 62. Now I need to shade it or do something. There we go. Now is that bizarre enough? Yeah. But you know that there's something probably nice going to happen here, you hope. And what's that? There's some common factor that brings sanity. Otherwise, we're in trouble. Okay, so you don't know if you're in trouble or not. So we'll just rewrite the problem. This is 62. So this is a little more challenging. That's good. Y to the third, I like putting the exponent in that's missing. Z to the first plus 3y to the second, z to the second, minus a 54 y to the first, z to the third. Now, why am I putting in the ones on those exponents? What is our rule that we're hunting for to do a GCF, known as the greatest common factor?
You want the
Okay, I'm hunting for the same letter that's in every term,
with the lowest exponent.
the lowest exponent. What happens if you don't see an exponent?
It's 1.
You're in trouble. You may think it's 0. You wouldn't think that, but some people might. What is the letter that's in everything?
Y, Z.
Z.
Y and a Z?
Just Z.
Y and Z.
Oh, no, it is Y and Z.
Y and Z.
Yeah.
Y, Z.
You see Y and Z in
Yeah.
each term. Agreed.
Yes.
Great.
Okay. Y to the first, Z to the first, because the 1 was the lowest exponent on Y and the lowest exponent on Z. Technically, you could divide YZ into this trinomial, or we can see if now we can simply show the result of that. YZ factored out, not divided, but thinking of it as a factoring, do you see a Y squared?
Mm-hmm.
And that, I hope, gives you a warm, fuzzy feeling.
Oh, yeah. It's like a hug from Mom.
Just like a hug, yes. A warm, fuzzy feeling because you see a second-degree term. That's good. YZ coming out of here gives you a plus 3YZ. Probably no fuzzy feelings yet on that one. But what about this? Why did I change the sign? Because I haven't looked in the term above. Is the best answer I can think of at the moment. I was into pluses. How about a minus sign? Now, 54 and what? The z squared is good because now I've got a y squared and a z squared and a yz in the middle. And that's good. Now, question, I might be done. Maybe this is prime. Okay? Might not be prime, but I don't know yet. But I do know if there's hope, it has to be like this. And furthermore, it's going to have to be a y. Now you may say, well, wait a minute, you had a y to the first, z to the first, now why did you take off the y, or the exponents? Because if I was going to be consistent and put a y to the first there, I'd have to put a y to the first here and a y to the first here, and you'd say y. Anyway, one of these is going to be positive and one's going to be negative because of the negative I had at the end. Now what are you going to do with the 54? You're going to factor it into pairs. Feel a bit like Noah? Take pairs of numbers on the ark. Okay, so 54, what do you have?
6 and 9.
Does the 6 and 9 hit you immediately?
Yes.
And I mean, you're lucking out right now because the difference is what? 3, and I wanted a difference because I had the negative. But maybe you didn't see that. So what are the other factors of 54? 9 and 6 is not what. Okay, 1 and 54, what else?
27.
Not so easy, huh?
27.
3 and 18, good. The point I'm making here, if the authors are kind to you, they've given you middle terms with the easy one. But if I want to play with your head, I could have put a 15 here. Then you'd be into 318. What else?
2 and 27.
2 and 27. I could have gone with a what? A 25 in the middle term. Huh? What else? Anything else? We've got a 2, a 3, a 1, a 6. I think that's it, isn't it, for 54? Other than the reversals that I don't have to worry about right now. I know that you can see the 6, 9 quickly, but just think of how much more difficulty you'd have. Let's say the middle term was 53. And you're into things like 2s and 3s and 6s, and you forget the freebie, 1 and 54. So I could make a number of problems out of this, some less kind than others. Okay, tell me where to put the 6 and the 9, and why.
The 9 goes with the plus.
Okay, so you're going to put the 9 with the plus and the 6 with the negative so that you have a positive 3y. Now, I'm not done because I nearly lost something. I'm looking at this and saying, gosh, I've got 9y and 6y. Whoops.
9z.
A z. So I need to have the z as part of that, so I have what? 54z squared. And now I have 9zy, which is yz. So a positive 9yz, a negative 6yz, which is a positive 3yz. I think I've got it. Perry, I see a question.
No, I understand.
Expression. The zy and the yz flips it around from here. But again, it's that commutativity. And that may be a little bit, you say, wait, I'm supposed to get yz, not zy. But zy is yz.
You're hurting me.
You're confusing yourself.
Just leave the letters alone, right? Leave them alone.
Okay. If I was going to try to go backwards now and take that last answer
Yes.
and try to figure it out, so I'd take the...
Binomials first.
And then,
Always. And then multiply through with your monomial GCF. If you do the monomial first and then do the binomial, you're making life much more difficult. Because with the binomials as they are, that as a FOIL product goes pretty fast in your head. You would have to write that down, then multiply through by your YZ, and then get up to here. Should you go through that step right now? Yes. The more of these you do, the better it gets. If you want to get better, feel worse for a while. Not everybody believes that. I can tell. Any questions before we go to another problem? Now we want to finish up with another more difficult, more interesting than this one. We'll leave that, Debbie. I've got to get back to the book and get one from my list of 80. So the list of 80.
You're enjoying saying that list of 80, aren't you?
Oh, yes, because that list of 80 is nice. We should have a list of 160. Uh-huh.
That's a bad man.
Okay, let's see what we can have some fun doing here.
54.
No, that's not fun.
Number 80.
What number?
80.
No,
That's not fun? That
not
was
yet.
very
I'm still hunting here.
58.
I know, watch it.
I'm looking at 58 or 59. We're hitting the same spot, so that's good. We're thinking the
No.
same.
No, I don't think
58.
Thanks for your help.
58. Interesting. Now the question is it too interesting? 5, 200. No, that looks good. I sort of like that.
Oh, it's going to be a 5.
Okay, let's try that, Debbie. 58. That looks sufficiently diabolical. Now, I'm having a little bit of trouble with that last number because it's too much light on it. We have what? A 125 m to the 4th, a minus 400 m cubed n, and a plus 195. Thank you. M to the second, into the second. Okay. Thank you. I could not read the exponents there. M is in every term. That's good. And the lowest exponent on the m that's in every term is a 2. So I have m squared. Now I think it's clear there's a 5 in every term. So I have 25 times 5 here, 5 times 80 here. The 5 here is going to go into that. We have what? 3, 9? 37. Which is it? 5 will go into this, 3, 4. Okay, 5 will go into that 3, leaving 4. So 39. Right? So it looks like a 5 is it. And I have 25 m to the second I don't know if this is good or not, because what am I seeing? A perfect square. But that's okay. Then minus what? 80 mn. And then plus 39 n squared. That's good. Okay, I wanted something interesting. We got it. Okay, so what are the 25 goes 5, 5, and 125, that's it. So this could go 5, 5, 125, and then I can reverse the 25, 1. Now what about the 39? That's 313 and 139. That's it, right? I mean, in a sense, they were bad, but not that bad. Okay, I have a 5m squared. Now here's the challenge. If it's going to work, I know I'm going to have an m here, and an n, an m, and an n, and they both must be negatives. And I didn't leave probably enough room. So the question, do we want a sum or a difference? A sum because the last term's positive, and then we have to do what? Take these as pairs. 15 and 65. Oh, life is good. Nobody felt good about that. Insincerity, insincerity. Okay, why did I feel good about 15 and 65? That gives me an 80. So I want 5, 5. So more space. 5m. And then, oh, a mess. Try to get that a little bit better. Now, what about here? A 3 and a 13, does it matter?
No.
Not in this case. So does it work? I have 39n squared at the end, positive. I have a negative 15n, a negative 65. Should have said mn. Negative 15mn and a negative 65mn, and that's a negative 80mn. And I've got the trinomial, and if I multiply through by the 5m squared, I have the trinomial up there. That was good. That was good. That was nice. For homework. Okay. We are all the way back on page 299. Nah. Let's see. We have some more interesting problems on page 300. If you need help, sort of look at the ones before 30 or before, but I want 31 through 62. I want to go up to, okay, 31 through 76 all. So 31 through 76 all. On that, we were listening to the Doors, I think, when we started. What is your close here, Debbie?
Roadhouse Blues.
Roadhouse Blues with Jim Morrison and the Doors. Have a great day.